Thanks, Alex. Yes, I have 25 minutes now. I thought I'll use that a little bit to try to dive slightly deeper than I could in the keynote into some of the changes that I was thinking about doing for Qt 6. Focusing really on Qt core only, as that's the heart of what Qt is and the heart of what we're using there. Can't go into all the changes. I'll pick out a couple of things. Talk a little bit, let's go about the container classes, slightly more in-depth than what we've had in the keynote. Recap a bit on the Unicode changes, go a bit more in-depth into meta type variant, improvements on mock on the meta object and the new property system. Those of you who have been here on the last session, you heard quite a lot of things about the meta object, the property system. Some of those things will change a bit in Qt 6, and I'll try to go a little bit into some of those changes. It'll be a bit in-depth for some of those things, but I hope you'll be able to follow those things, even if you don't know the implementation details there. Start off with the container classes. You all know about those. We talked about that in the keynote yesterday. A couple of things that are happening. The unification of QList and QVector is actually, I've got that merged a couple of days ago. So it's only QVector now. QList is an alias to it. Might break a little bit of source code, but it seems to be mostly compatible from the behavioral point. The main thing that breaks are forward declarations of QList. We're splitting QMap and QHash and away from QMultimap, QMultiHash. Those will be two completely separate classes in Qt 6, similar to what the STL and the standard library do. That will also mean that insert multi and unite, which are both methods on QMap and QHash, will be deprecated in 5.15. I talked about the standard pair, nothing really to go too much into details there. And I want to go back and take a step back and evaluate where we can use actually existing implementations out there and wrap our Qt API around those. Finally, there's a bit of work that I want to do to close the API gaps towards STL for our containers. If you look at the Qt containers, we have the Qt style API, but we also have an STL compatible API. Unfortunately, some of those are lacking a bit behind, where in some cases, missing certain move operators on QList. Erase takes an iterator, not a const iterator, as it does since C++ 11. In-place construction is missing. Some of those things, I think we not want to have those available now with Qt 6 also in our containers to make them compatible with whatever is there in C++ and C++ 17. A couple of changes that were actually planned that I would like to do there as well is I want to get rid of shared null. You usually don't see that when you're just using our containers, but all of our containers are implicitly shared with atomic ref counting. And if you default construct them, we usually assign a shared null implementation to them. So all those containers have one D pointer, and that one points then to a shared null instance, which is shared, has a ref count of -1 actually, and we'll need to always, when we add and remove a ref count, we need to check that it's not -1 and then do nothing. I want to get rid of that. Instead, just use a null D pointer, which means that the constructor can be const-exp much faster. We don't need to have a relocation there for constructing it. Referencing and dereferencing, changing the ref count doesn't need to check the ref count for -1 anymore. Instead, we'll need to check for 0 D pointer, but that's usually faster because we can do that non-atomically. But as a side effect, data on any container, whether that's QString, QVector, or anything else, might return a null pointer in the future. So you'll have to pay a bit of attention there in Qt 6. A second change is moving towards also what the STL does, is inlining the begin and end pointer for vector, string, and byte array. Currently, QVector, QString, QByte array are the size of one pointer pointing to the data. We'll have then in Qt 6, there'll be 3 pointers big pointing to a D pointer, which contains the reference count, and then the begin and the end of the data, all begin and size. We'll have to see about that one. This will give us quite a bit better performance. We can much more easily do things like compile time string constants, where we can say we have you just write a string with a quote or double quote and the U in front, and we can convert those const expr into a QString. And we have a much better compatibility with our view classes, QString view, byte array view. Final thing is that we can actually create substrings out of a QString or ranges, subranges out of a vector without having to copy any data, which is very nice for many of those the operations that people are doing on strings and vectors. I'd also like to see whether we can add a second template parameter for reference counting. There's a lot of places where people use one of our containers just in an implementation. They're never copied, they're never shared between threads, so we don't really need any reference counting on them. And not removing that code that does the checking of the reference counting, especially when you access the data of it, that checks is the ref not equals 1, then detach, will provide a significant performance improvement. So what I want to do is have a second template argument there, saying, okay, this is not reference counted, I know what I'm doing. And you have then the advantage, you can do all the operations on the QString or on the vector using the same API. But we can then afterwards go ahead and say, now I'm done, and actually I want to move it out over to a reference counted container. And you just move it over. That's something we can then do. And so we can avoid detaches on access, and then we have a zero copy move from the reference counted to the non-reference counted version and vice versa. Of course, when you go from reference counted to non-reference counted, we might have to take a copy if the reference count is different from 1. So those are changes that we're planning. As said, all of this is currently a little bit vaporware. We're working on it, but it's not implemented yet. But I want to have those things ready for Qt 6. I've talked about Unicode in the keynote as well. This is basically repeating a little bit what we've talked about there. Make sure that all text handling assumes Unicode. Let's get rid of Latin 1. Let's get rid of all the legacy encodings for text and not worry about those anymore. They'll be still available in a separate library if you really need them. But I think nowadays most people will not need them anymore. I've just looked up statistics on, for example, web pages out there in the world. 95% of all the web pages that you can access in your browser are UTF-8 encoded. There's very, very little legacy encodings left, and those are probably all web pages that haven't been updated for 10 years. We're assuming all the source code is in UTF-8 in Qt 6. This is something that's different from the C++ standard, which basically still can't agree on what the encoding or the encoding of the source code is supposed to be. I want to make that a statement for Qt 6. Unless you really know what you're doing, you change the compiler options for that. We want to assume UTF-8 as a source code. And actually, GCC and Clang already assume that by default. I think Visual Studio still assumes the local code page of wherever you are. But GCC and Clang already assume that, and I think nobody really noticed that it didn't really break a whole lot of things. But that means you can use then full Unicode also for your strings inside your source code, UTF-8 encoded. You can just, for UTF-8 encoded text, just write it with single quote, with double quotes, be done with it. Put a U in front if you want it to be converted to UTF-16 at compile time, so we can use it zero copy in a QString. And with that, we can then hopefully deprecate Latin 1 string, QString literal, and make all of that a lot simpler. Also deprecate and remove QString ref and QChar ref. Most people probably don't even know those classes exist and have not used them too much. But they are there, they're complicating our architecture. Qbyte array is currently defined to be Latin 1, and that does conflict with UTF-8. So we'll go the step and basically define that as ASCII only. So the couple of string operations you have on a byte array, like uppercasing, lowercasing, will work on the ASCII range, but nothing else. And with that, we can get to a simpler set of string classes, string and string view, and byte array actually for 8-bit data. It's not really text. Let's move over to QMetatype and QVariant. That's another thing where we want to change our implementations to give you a better experience. In Qt 5, qvariant actually has a set of handlers that basically allow you to convert any type to a variant, construct them, copy them. That's what qvariant needs to be able to do. Save them and load them from a data stream, compare them. And for that, we had a struct up there. You see that one qvariant handler. The problem was that struct, we had one per shared library, one in Qt core, one in Qt GUI for the types that are defined in Qt GUI, one in Qt widgets for the types that are defined in widgets. And we were chaining those handler structures and then trying to find the right one through a big switch statement. And any user-defined type was actually handled completely separate with a separate system through qmeta type. The problem was it's not extensible. User-defined pipes were handled very differently from the rest, and it was actually not really fast. And final problem with variant is that it does a lot of magic conversions automatically. You put in a byte array, you ask for a string, and you magically get a string out, and it won't tell you that it actually did a conversion. It's fine to have explicit conversions, but implicit, automatic defined conversions are very magic and usually not what you want. So for Qt 6, we want to fix that, get rid of those handlers in qvariant and use a Q pointer to a meta type as the ID in qvariant. Instead of an integer ID that we currently have for our built-in types, and then you can register your own IDs for your types, the ID will be a pointer to a meta type data structure. That data structure is something that we can then generate at compile time. And it means also that we can have the same handlers for qvariant, qmeta type, and unify the handling between our built-in types and user-defined types. With that, also improve performance, but there's some issues that we still need to solve on the way. We need to find a way to how we can deprecate those automatic conversions in qvariant in a good way so that you'll know when you're doing those and when you need to work with that. We'll need to find out how to handle compatibility for the old type enum that we have. And final last thing that we need in a very few places is we have a string name, and introspection, we want to look up the meta type by name. And that means we still need some way to register those and find those. There'll also be some improvements to the mock and the meta object. Those of you who haven't been in the last talk heard a little bit about some of those things in there. I want to improve some of the things in there. The first thing is I would like to make sure that the meta object system is directly usable by QML. We've had in all of the Qt 5 series for QML always some additional data that we needed to basically put in and store and generate at compile time. We had a set of tables there. If you're interested in the details, look for Qt property cache in the Qt declarative module, and then close your eyes very quickly because it's actually pretty ugly. But adding some flags here for knowing whether it's a QML var, alias property, and make sure that all those property flags are compile time constant data, because currently they still partially run data that you can actually set at runtime. So, for example, whether a property is designable is something that I can determine through a function at runtime. It's very sketchy, and I don't think we want to support that in Qt 6 anymore. Also, going into the meta object system, what we have in Qt 5 is the top meta object. You have a meta object, and it has a pointer to the parent meta object. This reflects the QObject hierarchy. So if you have a QObject and then QWidget deriving from QObject, the meta object for QWidget will have a pointer to the parent pointer will point to the meta object of QObject. Then you have additional data in there for string data and other data. I want to change that because the problem here is that whenever we look something up, we store, for example, signals and methods by index when we do signal slot connections. Whenever we look those up, we need to iterate over that chain to find the right index, because the signal index starts at 0 at the destroyed signal for QObject and then increments by 1 for every other thing. So the first signal in QWidget probably has a 2, and then the first signal in, let's say, QButton might have a signal index 5, and so on. So resolving those is linear in the inheritance steps. In Qt 6, let's make sure that I want to change that. I want to make sure that we can access the whole meta object hierarchy in constant time without having to iterate through them by having the pointers to all the parent meta objects available, and then change the signal index so that it has a local part inside the meta object and then the distance from Q object. So 0 for Q object, 1 for Q widget, 2 for Q button, and so on. And then with that, resolving getting the data for the signal handler is O of 1 instead of O of the inheritance steps. At the same time, we talked about Q meta type. Resolving type information is currently a bit slow in many cases. Type info, when we generate the meta object code that we're using to resolve signals and slots, we need to know the types to check that those are compatible between the signals and the slots. And those types are usually stored as a Q-variant type, which is fine for built-in types. But for user-defined types, we don't know those at compile time. Mock doesn't know them. So we store a string representation, the type name. And then we look those up at runtime and try to find the corresponding meta type information at runtime for that one. In Qt 6, if the meta type is actually a pointer to a type data structure, we can store that pointer directly, and with that, speed that up significantly. So those are some of the changes in the meta type meta object system. And then, as the last part of my presentation, I thought I'd give you a little bit more of a slight intro into the implementation of the new property system that I've been talking about yesterday a bit. Just to quickly recap, this is how things will look like from a user's perspective. You have any struct. You can add properties to the struct, width, height, border, and you can set, for example, in the constructor bindings, binding the width to the height, or the height to the width this way around, so that the height will always be the same as the width. It's a square item. And the border, maybe 10% of the width. And if you construct that item, you set the width to 100, then you can assert, you know that the height will be 100 as well, and the border will be 10. Very nice, easy to use, very nice syntax there, and we do a lot of magic to make sure this works. So let's go a little bit into having a look at how that magic looks like. So how do we implement such a Q property class? Start off with a simple thing. Let's leave out bindings for the moment. Very simple boilerplate. You have a template, class Q property, you put in the data. You have a value and a set value that one of them returning the data, the other one setting the data. And then for some boilerplate constructors and stuff like that. And ideally, to make it really a property syntax, you have an operator T, which returns the value, and an operator equals, where you can assign the value. Of course, you can add move assignment operators and other things in addition. That doesn't give you any bindings, though. So let's have a look at how could we do the bindings. This is probably the most trivial way to implement that I could think of. We add a standard function for the binding, initialize that as a null pointer. We have the data here as well, and then we change the value and set value functions. On the value side, if you have a binding, we basically just evaluate the binding and return that. Otherwise, and ignore the data completely. Otherwise, we return data. The set value function, basically, if there's a binding, it basically clears that one and sets the value again. And then we have a set binding function, which basically sets up the binding. Oh, so some braces missing, never mind. And, well, if you want a clear binding, to basically reset that and remove the binding. There's a couple of problems with this. First one is it's really inefficient because we are re-evaluating the binding every single time we call value and access it. And that could be complex, and there could be a chain of bindings there because you could access another property which again has a binding, and so on, and making this really, really expensive. The other problem is it uses quite a bit of space because standard function is actually pretty large in terms of memory usage. So this is not ideal. Let's try to improve on it. A couple of things. First of all, we want to evaluate the bindings lazily, and then we want to also see how we can do that. And evaluating them lazily requires quite a bit of work. It makes things a bit more complex. And this is still simplified from what we have for the real implementation a bit. We say we have a binding now, a pointer to that, and we have a list of observers. That observers are other properties, for example, that are subscribed to this property, or other bindings that depend upon this property. It could be anything, but it could also be something else. And we have the data. What we do then, if we have a binding, we check if it's dirty, and if yes, we evaluate it again. At the same time, then we need to register with bindings that are currently evaluating, meaning, if you, for example, have one binding, let's go back to the initial example, you had the binding, the height depended on the width. So if we ask for the height, and the height binding was marked as dirty, it'll reevaluate itself and basically call width. And then we need to know, when width gets called, we need to know, okay, height is currently evaluating, we need to flag that one as a dependency. This is the mechanism how we collect the dependencies that we have and can flag those as dirty later on if our own value changes. On the set value is easier. We have some check there that if the value didn't change, we return early, because then we don't want to avoid flagging anything else as dirty. Otherwise, we assign the new value, and then we notify all our observers that, we've changed our value. Flag your own, if the observer is a binding, flag it as dirty. And you can set a binding again with a standard function, but we then wrap that into a QBinding object. The binding object basically has a little bit more magic. We want to use something where we basically wrap the standard function into something else that we can, or the lambda, where we can then basically write directly into the data pointer that we have on the binding itself. It has a dirty Boolean, and those two things, and a little bit later, more things. And then we have a thread local variable that tells us, what's the current evaluation state of any bindings. So if we call evaluate if dirty, what we do is, we basically create an evaluation state. That shouldn't be a pointer, that should be a value on the stack. We swap the pointer with the current evaluation state and then evaluate the binding itself. That means the current evaluation state contains some data pointing to the current binding, and we can use that then afterwards to basically set up our dependencies and observers. I'm leaving out lots of details here. And what we do then, when we call that register with currently evaluating binding in the value getter, we basically check the thread local evaluation state. If one is defined, then we register our value and our own property there. On notify, we notify all the observers. That's usually a linked list or something like that, and they can mark their dependent bindings as dirty. So that's the basic idea behind this. As said, the code in itself has a lot more details. There are a couple of optimizations that we then want to do. We only want to use one pointer for bindings and the observer list, because usually on many properties you don't actually have a binding, but you do have observers, people that depend upon this binding. So in that case, we can move them into one UN pointer, use the lowest bit to distinguish whether that's a pointer to a binding or to an observer list. We can also use the second free bit for a QProperty bool and store the Boolean in another bit there, so that we don't even need the T data for property of Boolean. And the binding then also needs to have an observer list. So if you have a binding, the observer list pointer moves into the QBinding class. That helps us optimize things and gets things a bit better. And to give you some idea of what that does, I've done a simple evaluation of the performance with a new C++ based bindings and the current QML based bindings. Code is on the right hand side. We just create two bindings, and we set one binding to or the binding up to be the double of the other value of the other property. In Qt Quick, we also have that same thing, two properties, one with the value 2, and value 2 is just the double of the regular value. Evaluating those in a loop and measuring performance shows that the binding is actually almost 10 times faster. 94 nanoseconds is what I measured on the C++ side. the QML-based binding was 900 nanoseconds per evaluation. So a huge speed improvements, and we will be able to do more, because what we're having here is that we can evaluate, because the bindings are flagged dirty, we can do binding evaluation much more lazily. We only reevaluate the binding when somebody asks for the value of the property. In QML currently, in Qt 5, we're doing that through a push mechanism. If the binding is dirty, if some value changes, all the dependencies will get reevaluated immediately, which means if a binding has 3 dependencies and all of those change, the binding will get reevaluated 3 times, even though nobody asked for the value of that property in between. That's something that will improve things quite a bit. So to sum that up, we'll have a very nice and intuitive property API. We'll have support for bindings from C++ in Qt 6, and I think that will change radically what you can do with Qt, because I've seen that in QML. The success of QML was very much because of the support of those bindings, the concept of bindings. That changed how people could do programming. And I believe that we can do the same thing in the C++ side. And we're getting a huge speed improvement over current QML, and we can use that in QML in Qt 6 as well. All the details, the patch, work in progress patch for getting those bindings into Qt. Up there's the link on code review. If you're interested in all the details, all the things I left out, it's around 2,000 lines of code in total for everything and to fletch out all the details. Have a look at it. And with that, thank you very much for listening. I don't know. Do we have time for 1 or 2 questions, Alex?
Hi. If you say that these bindings are lazily evaluated and basically are only done when you actually ask for the value, does that also mean that you don't get signals that basically properties have changed anymore?
Yes and no. The things is the current mechanism for Q properties that we have has a getter, a setter method, and a changed signal, right? The new binding mechanisms per default don't have any changed signals anymore, but you can subscribe to change notifications there, and that will then mean that you get some sort of signal notification. But by default, you need to first subscribe to it. Otherwise, it's similar to the connect statement. You will get the notification that it has changed immediately, because we can flag things as dirty. It's a bit difficult because you might get them a bit more often. You could happen to get a changed signal even if the binding expression in the end re-evaluates to the same value. So that's a little bit of a change of behavior, because we don't know before we ask the value.
Okay.
But this is some of the details we're still working on and trying to figure out what to best solve and what kind of behavior will be the best for our users.
And can you mix and match with the current property system? Because
that's the plan, yes.
There's a lot of legacy code using that, of course.
Yes, of course. I mean, we will still support the current property system.
Did I get it right that QString will be UTF-8?
No. QString will stay UTF-16. I've actually had a look at that one. And it's not doable without really breaking so much code out there in the world that I don't want to do it. Because there's a lot of implications in terms of what's actually QString length then. What's, when you iterate or when you ask for the data. It's not practical and doable, and I don't think it's a big problem, because you can prefix your strings or your character literals with a small u. The compiler will generate UTF-16 for you, and that we can use zero copy now in Qt 6.
Hi, can I create these properties at runtime, so as a replacement for dynamic properties?
Those are compile time here. Runtime, we have the existing property system allows you to use the runtime generated properties through the property set property API. I think that will continue to be there. But those here are all compile time. We can't do those runtime.
So as far as the changes go for Qt 6, will there be a guide available for the migration from the previous source
course.
code? Or maybe, I'm sure there will be, but by like how soon we can see that happening? Maybe there's a Jira ticket that logs those things that we can take a look at beforehand. So that we're writing a lot of code to make sure that it's in line with Qt 6 so that we don't have to make a lot of changes.
Yeah, what the plan that we're having is trying to make sure that we get all the things that you need to fix into Qt 5.15, so that if you turn on deprecation warnings for 5.15, you'll see most of those things, and that should cover, hopefully, most things, 90% at least. I'm sure we'll miss something, but the goal is to get as far as possible with that in Qt 5.15. Apart from that, we'll of course have some migration guides and other things, but my goal is still to make sure that the porting is easy and straightforward, and that it doesn't require too much effort from you.
In one recent emails on the mailing list, Thiago mentioned that Qt 5 requires C++ compliant, C++ 11 compliant compiler, but not the standard library. But in your slides, you mentioned that QPair will be implemented on top of standard pair. Does it mean that we will require a standard library?
We do. This is not quite true. We do require a standard library. We just don't require everything from it, and we are careful in what we require, especially on the header files. But we've had for a while the policy that in the implementation of Qt, we can use the standard library pretty freely. How much we require in terms of our APIs is a different question, but I think those are relatively straightforward and easy. I mean, we want to be a bit careful not to require everything from the standard library in our headers, also just to keep compile times reasonable. But certain things are things we are evaluating, and those are still things to evaluate and to look into. I think QPair standard pair is an easy one because it unifies the two. The API is exactly identical. There's no difference. Actually, standard pair has a little bit more functionality than QPair. That's a bit more of a tricky question. Looking into those, I'm not sure what we're going to do with those, but I don't think we can get rid of qvariant, and some of the things we have very nice support also for extending and for things that we need also on the QML side for dynamic stuff. So, to be looked into.
I have two questions. About the first one about QMap. Will it be possible to pass custom comparator into template as a template parameter?
Good question. Let's see what we do when we implement it. But it is certainly having custom methods for hashing and also comparison operators for QMap could be a good feature to add.
And second one about internal buffer of QList or QVector. What kind of this buffer? It will contain the whole object, or as was implemented now in QVector, or as in QList when Q pointer just contains only pointer.
So the difference between QList and QVector for large objects is that QList was newing the object on the heap as a copy, and then had just a pointer to that. It will be similar to what we currently have in QVector. If you really need pointers to objects to store that, use exactly that, right?
Okay, thanks.
You're welcome. And we've seen that for most use cases, that was actually better and more performant.
Is there any chance to fix qvariant so it can be put in the key of an associative operator, an associative container? There was a problem with one of the operators.
I think there is certainly a chance, patches are welcome, but we can have a look at that if you report it on Jira.
I think it was known, it was discussed in the mailing list, but it's a compatibility change. So that's
yeah, but with Qt 6 we can change some of those things.
Are you planning to improve the single slot mechanism, especially the Lambda mechanism that cannot be unique slots?
What do you mean? Not sure.
I think the slot, if you have a Lambda slot, you cannot make the connection unique because of the Lambda. I think it's...
Of course, you can connect to Lambdas today in Qt 5.
Yes, but if you make a Lambda slot compared to a function, the connection cannot be one time only. There cannot be only one connection, but like unique connection and Qt connections. And you cannot, with the Lambda, you cannot make unique connection because the Lambda was implemented later. And I think that's kind of a flaw. I don't know.
Okay, well, I would propose if you have some problems there and bugs there that don't work, file a bug report and we'll try to have a look and see what we can do.
I think it's by design. There's also a blog by Thiago concerning that.
Yeah, I think it, you mean the unique connection for that? Yeah, that's difficult to do because of the compilers. No. Okay, yes.
Maybe I missed it, but what are the plans to ditch implicit sharing in terms or in favor of short string optimization? Is there any plan to do it?
No, there is an idea of having short string optimizations for QString and QByteArray. That doesn't mean we would ditch implicit sharing for longer ones. I mean, implicit sharing is in that respect transparent, and we can go ahead and say, okay, we're doing a short SSO optimized short strings and still have the implicit sharing for the larger ones. But that's to be checked and discussed, and we'll have to check how much sense that makes and how much it really helps.
Going once? Twice? Thank you very much, Lars.
Thank you.